In the beginning, there was darkness, and then bang, giving birth to an endless expanding existence of time, space, and matter. Every day, new discoveries are unlocking the mysterious, the mind-blowing, the deadly secrets of a place we call the universe. Throughout its more than 4 billion years of existence, planet Earth has endured some extremely rough days. But were they the very worst? Was it a shattering encounter with a planet that got too close?
Had anything been there, it definitely wouldn't have survived.
Or a hot shower of deadly rays that almost scoured the planet clean of life?
The blast from the impact would have laid waste 1,000 miles in every direction. It's literally the sound heard around the world.
From runaway volcanism that led to vast extinctions, to tiny microbes that triggered a global deep freeze, life has teetered perilously close to the brink, time and time again.
More life died then than any time since, and maybe any time before. This was the biggest and the baddest of them all.
Are the darkest hours behind us, or lurking in the distant future? Take cover as we count down the 7 worst days on planet Earth. You may think you've had some really rough days. Stuck in gridlock traffic, dodging a sea of humanity on the way to work, or trapped in a torrential downpour or blizzard. But they can't even begin to compare to the 7 worst days on planet Earth.
Throughout its history, Earth has experienced some really bad days. Days that have killed off life, created life, restructured the planet as a whole. All of this together has formed the Earth that we live on today. But during those really bad days, we certainly wouldn't want to be here.
From our point of view, Earth has been through some pretty rough days. Catastrophic impacts that have really changed the face of the planet and changed the makeup of the flora and fauna, the animals and plants on the planet.
One of Earth's worst days came early in its history, when an uninvited guest barged into our neighborhood and threatened to destroy the planet before life had a chance to blossom. Blasting in as the 7th worst day on Earth, the Theia impact. About 4.5 billion years ago, our solar system was a battle zone. Giant boulders collided and coalesced to form planets. Infant Earth took hit after searing hit.
If we could somehow magically transport ourselves back in time to be on the early Earth, it'd be very interesting, I think, to watch one of these large impact events. The surface of the Earth itself was probably heated to a near molten state. The atmosphere would be very dusty, it would be very hot. So it would be a very alien world to us, one that we actually couldn't survive on just standing like we are here today.
Pounded by incoming rocks, Earth slowly grew to nearly its present size, developing a solid crust, a thick mantle, an iron core, and a hot, stormy atmosphere. Some speculate that life may have taken a tenuous hold, but then, disaster. A neighboring planet named Theia had been edging into Earth's orbital path. The intrusion ended in the most disastrous way imaginable. A collision of worlds.
It was a very violent event. You can imagine something the mass of Mars, about 10% the mass of the Earth, whacking in from space and blowing all this material in. Whatever was on the Earth at that time was radically changed by this event.
When a Mars-sized object whacked into the Earth, that was a bad day on Earth. Had anything been there, it definitely wouldn't have survived.
It took hours for the full scope of the catastrophe to unfold. As the cores of the two planets melded, Earth's atmosphere was blasted into space. Its crust liquefied at over 2,000 degrees Fahrenheit. And vast portions of both Earth's and Thea's mantles were ejected into orbit.
It's not at all like what you see in the movies. You can sit down and have a cup of coffee, and it's still going on. These are, big objects take a long time to occur. So these aren't the normal flashes you think about of bullets hitting a wall.
The plume of ejected material created a vast orbital ring before coalescing into a new companion for the Earth, the newborn Moon.
That fully fledged planet merged with the Earth. The iron cores would have come together, and the silicate mantles were left on the Earth and also accreted into a disk that was orbiting the Earth. This disk, most of it came back and crashed back onto the Earth, but then a portion of it reformed and over time has been pushed out and has become the Moon.
It took about 150 million years for Earth to stabilize and its molten crust to re-harden. But although the Theia impact was a very bad day on Earth, it was a very good day for its ability to sustain life.
When the Moon formed, it stabilized Earth's axis of rotation. Otherwise, gravitational tugs from other planets would have caused it to chaotically vary, and that would have been bad for long-term climate stability.
Would we even have life as we know it if that impact had not taken place? Without a moon, you could really have a case where your tropics, within hundreds of thousands of years, could rotate and become the Arctic or the Antarctic, and you kill everything.
With the impact over and the Moon now providing orbital stability, the stage seemed set for a quiet future. But that was not to be.
You form the planets, you form the Moon, everybody's happy, and all of a sudden, something terrible happens.
Earth was suddenly caught in the crossfire once again. Number 6 on our countdown of worst days, the late heavy bombardment. Approximately 150 million years after the Theia impact, the Earth's crust cooled. Some speculate that early oceans and even life may have evolved. But another cataclysm would wipe the slate clean. In the far reaches of the solar system, the orbits of the outer gas giants began to fluctuate, disrupting vast swarms of asteroids and comets. Trillions broke loose from their orbits and plunged inward toward the rocky planets, launching an era of fiery destruction known as the late heavy bombardment.
We know asteroids the size of Texas hit the Earth. Any impactor that big causes the entire ocean to go away. We sterilize the Earth over and over and over. So the inference we have is that life evolved over and over and over just to be snuffed out again by these large impacts.
The relentless bombardment gouged out craters thousands of miles wide, and the hits just kept coming for at least 200 million years. Today, billions of years of erosion and shifting plate tectonics have erased any trace of the cataclysm from the Earth's surface. But it's a different story on the cratered face of the Moon.
We can see very clearly its record on the face of the Moon. The lava-filled basins were formed during the giant impact events that occurred during the late heavy bombardment. And so we know that large objects hit the Earth during this time.
But this celestial rain of fire may have had a silver lining, literally. New evidence suggests the late heavy bombardment delivered precious metals to the surface of Earth. Things like silver, gold, and platinum. Earth's original store of these elements had sunk into its molten iron core as the planet slowly cooled. But now, with our planet already solidified, this new supply of materials remained near the surface, able to be mined by future humans.
Today's technologies depend on a lot of the heavy elements that were delivered to the Earth through impacts. So it may have been very difficult for the life, if there were life on Earth during the heavy bombardment, but it was very good for the Earth's crust to have all of these materials that we now depend on delivered to the surface of Earth through impacts.
The late heavy bombardment was Earth's true baptism by fire. But now, as we reach number 5 in our countdown of the planet's worst days, Earth catches the worst cold in history. A climactic crisis so chilling that life itself was in danger of being frozen in its tracks. Both the Theia impact and the late heavy bombardment turned Earth into an inferno. But now, as we continue our countdown of the 7 worst days on Earth, we skate forward in time to a catastrophe not of fire, but of all-encompassing ice. Number 5 on our countdown, the frozen cataclysm known as Snowball Earth.
We had these bad days, and a snowball Earth is much longer than a bad day. It's a bad hundreds of thousands of years. Snowball Earth is that the planet becomes a snowball. It cools enough that the oceans freeze down to 10 feet, 20, 50 feet thick. Imagine the Arctic sea ice we see now, except the whole planet has that.
During a typical ice age, glaciers invade the temperate zones, often reaching as far south as modern New York or Paris. But during Snowball Earth, the glaciers just kept coming until they had encircled the entire planet and frozen the oceans to a depth of up to a mile. As average temperatures plunged to minus 75 degrees Fahrenheit, the equator grew as cold then as the South Pole is today. And this global deep freeze may have happened not once, but twice. The first episode beginning 2.4 billion years ago.
During the Snowball Earth phase, the entire Earth has a climate quite similar to modern-day Antarctica. It's extremely cold, extremely dry, extremely windy, extremely unhospitable to life.
The Snowball Earth hypothesis helps explain the discovery of glacial deposits in areas that were once at the equator. It's theorized that as the glaciers marched on from the polar regions, they reflected sunlight back into space and created a powerful feedback loop, turning the thermostat relentlessly lower.
If the polar regions get too large, if the snow and highly reflective ice coatings get too far down in latitude, they reflect more light back into space. The Earth gets cooler, the ice goes closer and closer and closer to the equator. So it's thought to be kind of a runaway process. This leads to a freeze over of the Earth.
But what caused the first Snowball Earth? Scientists think the culprit actually may have been life itself.
The gas that was most prevalent when life first appeared on the Earth wasn't oxygen, it was methane. Creatures at that time, single-celled bacteria, would have used methane as part of their normal living processes.
Methane is a phenomenal greenhouse gas. So if you had a lot of methane in the atmosphere, you had likely very warm temperatures.
But 2.4 billion years ago, a new group of underwater microbes began absorbing energy from the sun in a process called photosynthesis. By converting carbon dioxide and water into energy, photosynthesis polluted the Earth with a toxic new waste product, oxygen, vast amounts of it.
Prior to 2.4 billion years ago, oxygen was a poison, and any life that was on Earth did not use oxygen. It was considered a waste gas. All of that life that didn't like oxygen was exposed to this rich oxygen environment, and it caused a great deal of stress.
Methane creatures were happy to live in this oxygen-free world, and when oxygen finally does appear, it was like the worst calamity in their history.
As oxygen flooded the world, it oxidized methane, turning it into carbon dioxide. The methane-consuming creatures died off in a vast extinction event called the Great Oxygen Catastrophe. And as Earth lost its warming blanket of methane gas, the planet froze over. But if oxygen-producing life was the primary trigger of the first snowball Earth, that life now needed to find a warm place to escape the disaster it had caused.
The Earth at that time was even more energetic tectonically than it is now. The formation of the Earth produced enormous heat. That heat comes to the surface. It's slowing, but back then, many more volcanoes. Around every volcano, there would have been this melted lake-like zone where life could have thrived.
To show how volcanism could have carved out cozy niches for life, all you need is a blowtorch and a big ball of ice.
We're here at Carving Ice, an ice house owned by Roland Hernandez, an amazing ice sculptor who's created for us this hemisphere of solid ice, which represents Snowball Earth. We've placed it up here on this dolly so that we can heat it from below with an industrial blowtorch to represent the type of heating that we would experience on Snowball Earth from volcanism deep beneath the surface.
Now let me just light this up. All right, passing you the torch.
Okay.
Scientists suspect that the extreme heat pressure generated by volcanism beneath the Earth's surface would have created cracks in the ice for life to take refuge.
Okay, so you can see how the cracks have formed all throughout the ice along the top here. These are very similar to the types of cracks that would form during a Snowball Earth event. It's in these cracks where you can get the mixture of a little bit of liquid, a little bit of heat, a little bit of chemistry. In other words, the perfect ingredients for generating an environment where life can take root and even thrive.
Volcanism wasn't just key to life's survival during Snowball Earth. It also may have forced the glaciers to finally retreat.
So you've got all of these gases that are coming out of the volcanoes, things like water vapor, carbon dioxide, sulfur dioxide, for example, which are escaping into the atmosphere. And over time, over tens of millions of years, you're building up these levels of greenhouse gases. At some point, it's going to get so warm in the atmosphere that the ice begins to melt.
Both episodes of Snowball Earth, the first 2.4 billion years ago, and the second 600 million years ago, placed profound stresses on early life. But oddly, both were followed by enormous flowerings of new species.
We know from the sedimentary record that just before animals bloomed into existence, an enormous amount of phosphorus came into the ocean. There were big rocks of phosphorus. They eroded. As that erosion occurred, phosphorus levels in the ocean rose. All of a sudden, life is able to just bloom. This may have really caused the diversification 2 times of the microbial world at 2.3 billion years ago, but more importantly to us, it really probably helped the diversification of animals at 600 million years ago.
Although Snowball Earth produced some of the planet's harshest weather, life not only managed to survive, it bounced back stronger than ever, which is why this disaster only ranks as number 5 on our list of worst days. But as the countdown continues, forensic evidence is finally emerging that just may explain a far deadlier cataclysm. A mass killing spree that stands as the oldest murder mystery on the planet. So far, on our countdown of the 7 worst days on Earth, we've seen our planet battered during the moon-forming impact, baked by the late heavy bombardment, and almost completely frozen over by Snowball Earth. Now we travel forward over 100 million years as the world is rocked by one of the greatest mass killings in its history. Number 4 on our list, the Ordovician extinction. In the billions of years of life on Earth, 99% of all species that ever lived have ultimately vanished, mostly due to 5 mass extinction events. The first was during the Ordovician period, 450 million years ago.
The mass extinction during the Ordovician is the most mysterious of the so-called Big Five, simply because it was the one that was the oldest. Everyone after that was closer to us in time, and the further back in time you go, the more fuzzy our scientific view of the past is.
During the Ordovician period, the globe was covered with 3 major oceans and 4 supercontinents. The land was still barren, but the oceans teemed with life, including brilliant corals and the planet's first fish. Then, a mysterious cataclysm swept the seas, and 60% of life on Earth vanished.
There's a couple of possibilities. Number 1, it got cold again. So why would it have gotten cold? Well, it could have been that plate tectonics moved all of the formerly warm continents down to the polar regions, and that dropped the temperature of everything.
For years, scientists blamed the Ordovician extinction on a devastating ice age. But now some researchers propose that the mass killer could have been something from the cosmos, like a gamma ray burst, the biggest blast in the universe.
A gamma ray burst is a colossal explosion of a star that occurs asymmetrically. There are 2 oppositely directed beams of very energetic, high-speed particles and radiation that go zipping through space, kind of like a laser beam. If that beam is aimed right at Earth, it can cause significant damage here.
A large burst would vaporize 1/3 of the planet's protective ozone layer, and creatures on the side of the Earth facing the onslaught would suffer lethal radiation exposure. The destructive energy of a gamma ray burst can be demonstrated here on Earth.
Here's our globe representing the Earth at the end of the Ordovician period, a time when one group of scientists thinks that a gamma ray burst may have triggered a mass extinction. The paper represents the Earth's ozone layer, and the gamma ray burst is represented by this propane torch. Eight, 9, 10 seconds worth. That's all they say it would take to destroy about 1/3 of the Earth's ozone. So, of course, the gamma ray burst didn't actually torch the Earth, but it did destroy the ozone that it encountered, and it would have messed with the chemistry of the ozone molecules on this side of the globe. And when the ozone was destroyed, UV radiation can penetrate to the surface, and the ultraviolet radiation is very lethal to life. It's very destructive to DNA. So it may be that a gamma ray burst destroying the ozone layer contributed to, or maybe even triggered, a mass extinction at the end of the Ordovician.
In addition to depleting the ozone layer, a large gamma ray burst also could have ripped apart nitrogen and oxygen molecules in the atmosphere, producing a gaseous smog of nitrogen dioxide that blocked sunlight and set off a secondary disaster, an ice age.
It's not clear whether that could have been caused by a gamma ray burst, but at least part of the Ordovician extinction seems to have been marked by a huge decrease in the number of surface-dwelling creatures, like on the Earth's surface or in the surface layers of the ocean. That may well indicate that it was ultraviolet radiation that killed him off, rather than some other factor.
A gamma ray burst could be one explanation for the first mass annihilation of life on Earth. But a startling new hypothesis points to a different cosmic force, a bizarre and potentially deadly phenomenon known as a bow shock.
A bow shock forms when there's compression of material in front of a moving object. So for example, if you have a boat zooming along, it creates a wave, a compression in front of it that then bends around as the boat moves through. Well, our galaxy is moving rapidly through space, so it can compress intergalactic gas in front of it, heating it up, creating cosmic rays, and some of those cosmic rays can then hit the Earth.
Our solar system oscillates through the Milky Way, traveling above and below the main disk of the galaxy every 64 million years. Once outside the galaxy's protective magnetic field, our planet is vulnerable to deadly cosmic rays generated by the galactic bow shock. Much like a wakeboarder on a lake.
Wakeboarding would be a reasonable example of a bow shock in space. While the wakeboarder is well within the confines of the bow wake of the boat, the water is very calm and smooth and he has no trouble standing up. But during those periods when he moves out towards the edge of the wake, the water becomes a bit more turbulent and a bit more chaotic, and he has trouble standing up. The same thing is true in space. For most of the time, the Earth and Sun are well within the protective confines of the Milky Way galaxy's magnetic field, protecting it from the cosmic rays and other radiation that's coming in from the bow shock. But during those periods when the Earth and the Sun rise above the galactic plane, it's much more vulnerable to all of these cosmic rays coming from the bow shock.
Fossil records indicate that the biodiversity of many species may increase and decrease in 62 million year cycles, those cycles closely coinciding with the times of greatest exposure to cosmic rays from the galactic bow shock, which occur every 64 million years. Could the two events be connected?
Two of the mass extinctions happen to have occurred at about the time when the Sun was highest above the plane of our galaxy. That suggests that there's something about that particular location that's special, causing these mass extinctions.
During the Ordovician extinction, Earth could have been blasted with enough deadly radiation from the galactic bow shock to unleash genetic mutations and DNA damage that wiped out over half of all species.
This is not yet a well-tested idea. It's just out there on the drawing board, but it could explain some of the possible periodicity in Earth's mass extinctions.
But while the Ordovician extinction was fatal to most species, some grasped at the opportunity.
It's like pulling weeds out of a garden. You sort of clean out and weed out and thin out. That seems to have happened in the Ordovician mass extinction. Some creatures which died out allowed others to diversify.
the Ordovician was the first mass extinction, but hardly the worst. Number 3 on our countdown of the worst days on Earth. It's the most famous die-off in prehistory. But if you think you know what killed the dinosaurs, you may be in for a surprise. Because some scientists now argue that the common explanation of a single giant impact on a single disastrous day is itself about to be blasted away. In our countdown to the very worst day on Earth, no catastrophe has been the subject of more public fascination and sensational headlines than the bombardment that ultimately cleared the path for mankind. But today, controversial new hypotheses challenge the concept that a single disastrous impact wiped out the dinosaurs and led to the third worst day on Earth, the KT extinction.
$65 million years ago, we would have seen a world something like Africa in terms of the number of animals out there. But instead of big mammals, we had big dinosaurs. Herds of triceratops, herds of duck-billed dinosaurs, small to big predators, the largest being T-Rex.
Dinosaurs ruled the prehistoric world for almost 200 million years. Then something took out 2/3 of all living creatures, including the giant beasts. After years of searching for clues, most experts now agree that a single cataclysm doomed the dinosaurs.
The evidence for an impact of a 6-mile-wide asteroid 65 million years ago is about as good as anything gets in science.
65 million years ago, a rock the size of Mount Everest barreled down from the sky and slammed into the Yucatan Peninsula near modern Chicxulub, Mexico. The impact unleashed an unstoppable chain of destruction, first locally, then across the globe.
The KT is an asteroid-driven extinction. A big rock from space came down, clunked a few dinosaurs on the head, but the kill mechanism was really the secondary effects of this. It would have been darkening of the atmosphere, acid rain, a change in the entire biosphere.
Proponents of the single impact theory point to a convincing array of evidence, including high levels of the asteroid element iridium at the KT event's geological boundary, or death layer, and of course, the smoking gun itself, the underwater crater in modern Mexico. But is this cold case finally closed? Some scientists now argue the Yucatan asteroid had accomplices.
There seem to be various causes that can trigger these, and in some cases, several causes come together in sort of a confluence of bad circumstances to provide a particularly damaging extinction event.
Millions of years before the KT extinction, vast lava flows had been pouring out of the Deccan Traps, a series of lava beds now located in southwest India. These flood basalts once spewed out enough magma to cover 1 million square miles and belched up a toxic brew of gases that could have altered the climate around the world.
That period of eruption is pretty coincident with the extinction 65 million years ago as well. In fact, they were going on for millions of years before the KT impact and before the extinctions. And so perhaps could be a complicating factor.
In this scenario, the dinosaurs received a double knockout blow. First, the rampant volcanism of the Deccan Traps, then the Yucatan impact. And a small group of dissenters goes even further, claiming that multiple asteroids struck Earth at roughly the same time, 65 million years ago. According to them, the Yucatan impact wasn't the largest, only the best documented.
Some people think that there may have been multiple impacts, a shower of impacts, for example. Perhaps they came from a single object that broke apart.
Supporters of this hypothesis point to a suspicious geologic feature, a 370-mile basin off the coast of India, more than 3 times larger than the Yucatan impact site. But controversy swirls around this so-called Shiva crater, named after the Hindu god of destruction, including whether it's even a crater at all.
While this feature certainly looks circular and looks crater-like, there's no other evidence that it's an actual impact structure.
For some, the dinosaur die-off debate rages on. But most scientists agree the apocalyptic event was a very fortunate day for small mammals that were no longer dinner for T-Rex.
Had it not been for the KT impact and the volcanism that was also at the time of the extinction of the dinosaurs, the mammals probably wouldn't have risen to the prominence that they did. And thank heaven for the rise of mammals, because that led to the rise of humans.
The KT extinction raises a sobering question. Could humans one day go the way of the dinosaurs? That's what viewer Tom Moore from Adrian, Michigan wanted to ask the universe. Will Earth be struck again by a KT-sized asteroid?
Well, Tom, Earth could definitely be hit by another KT-sized comet or asteroid. They're out there. The good news is we're tracking the positions of most of the big ones. So if we ever find one with Earth's name written on it, hopefully we'll be able to deflect it before it reaches Earth.
The KT event toppled T-Rex, but it only ranks as number 3 on our countdown of worst days on Earth. Number 2 was the mother of all extinctions, the greatest die-off that life on Earth has ever suffered. It's also been one of the biggest unsolved mysteries in science until now. As we near the climax of our countdown, we reopen one of the oldest cold cases. An unsolved murder mystery that happened 250 million years ago. Almost 200 million years before the downfall of the dinosaurs. The second worst day witnessed the greatest mass extinction in the planet's history. A cataclysm known as the Great Dying. During the Permian period, Earth was a wondrous world of mammal-like reptiles and exotic sea creatures. Then, 90% of all life disappeared from the planet.
This was a bad few 100,000 years on planet Earth, but it was certainly the most catastrophic. More life died then than any time since, and maybe any time before. This was the biggest and the baddest of them all.
For decades, scientists have sifted through clues, struggling to solve the mystery of the Great Dying, when the survival of life itself seemed to hang by a thread. One of the prime suspects, a supervolcano that tore Siberia open for hundreds of miles, erupted for at least 1 million years, and produced the greatest lava flows ever known. Enough to bury the entire United States thousands of feet deep.
This wasn't a single giant volcano, it was simply cracks in the earth, and you're like pumping out lava. It's like a fire hose spewing lava everywhere. Well, that certainly would have killed anything in its way.
It's believed that you had these beds of coal on what is now Siberia, which then had lava erupting underneath them, burning the coal, putting all sorts of noxious greenhouse and other toxic gases into the atmosphere, and really putting strong stress onto the biosphere.
The increased global warming was fatal to most animals. But plants usually thrive on carbon dioxide. So why did they also succumb at rates that have never been equaled?
there's a second killer in the story that we think and just now discovering, and that's the presence for the first time on the planet of massive amounts of hydrogen sulfide gas. The same stuff you see with rotten eggs. That's a true poison. And it, with the heat, combined, I think, to cause this greatest of mass extinctions.
If the scientific jury is still debating the cause of the Permian-Triassic extinction, no one disputes that those were the darkest days for life on our planet so far. But life on Earth cannot and will not survive an event that scientists predict is as unavoidable as death itself. The #1 worst day on planet Earth, the solar apocalypse. In 5 billion years, our sun will reach the end of its life. As it exhausts its nuclear fuel, it will undergo a disastrous transformation, bloating into a red giant star, 200 times its original size. As it swells, it will first engulf Mercury, then Venus. The incinerated Earth will either be pushed to a higher orbit or swallowed itself. The good news? Humans won't be around the day our sun incinerates Earth. The bad news? We will have been roasted long before.
The sun gets brighter about 10% every billion years. And so in less than a billion years, the sun will be bright enough that it's predicted that it will pump basically most of the carbon dioxide out of the atmosphere. And so things that rely on carbon dioxide, like plants, are going to have a hard time surviving in a natural world.
As plants shrivel and oceans evaporate, biologists predict a future mega mass extinction. The age of animals will end in about 500 million years.
We have as much time in the future to be alive as an animal as we've had in the past. We're halfway through. That's a sobering thought.
We've seen Earth smacked by the giant moon-forming impact, strafed and sterilized during the late heavy bombardment, then frozen into a giant snowball. A cosmic force ravaged an ancient water world during the first mass extinction, followed by a near-total extinction during the Great Dying and the spectacular fall of the dinosaurs. What else lies in store before our planet is ultimately baked by the sun?
Earth will certainly continue to experience disasters all the way up until the very end, when the sun's red giant phase brings an end to the story.
History has proven that Earth is an unpredictable planet, orbiting in a very dangerous galactic neighborhood. To survive, mankind must learn from the worst days of our past and try to prepare for whatever the cosmos might throw at us. Only by increasing our knowledge of the universe can we hope to thrive and fully enjoy our final 500 million years of life on Earth.